आ रहे हैं जबकि वन को कितना चले हमें तो बताइए, हमें बस ये बताइए हम कितना चले, ये एंगल कितना था, ये कितना था, मतलब हमें मतलब ये थीटा पता है, ये थीटा एंगल पता है और ये पता है, तो कैलकुलेट करके मतलब हम लाइन में रखेंगे।
रोटेटिंग क्यों दिख रहा है? हाँ, इसमें सिमेट्री चेंज हो रही है और इल्यूजन की वजह से हो रहा है ये। Determine the height, loops, curves, and the speed of the machine, etc., so that everything is safe and ready to use.
आप polynomial
calculus
वो polynomial
एक सेक्शन रोलर कोस्टर का
जैसे थोड़ा जगह बनवा के उनसे बच्चों से पूछो 2 मिनट कम का, जैसे इंटरव्यू टाइप से कि भाई आप क्या डेमो है, क्या दे रहे हैं, वो चीज़ें फिर झरने का लेना है, कैप्चर कर लेना। उधर एक बार बीच में झरने का
सर बेस प्लस परपेंडिकुलर इक्वल टू हाइपोटेन्यूज, ए बेस है, बी परपेंडिकुलर है, ओड है, ये ए टोटल नंबर 8 है, ओड है,
आप अकेले बेटा और भी? अच्छा, वेरी गुड शाबाश अकेले जो जितन को भेजना 6 नंबर पे। ओके सर।
बोल देती
और मल्टीप्लाई बाय 9, ठीक है। अब जो तुमने नंबर सोचा ना, जब 2 डिजिट का होगा या 3 डिजिट का होगा, उनको मैच प्लस कर दो। हाँ, जैसे 12 आया तो 3 हो गया, ठीक है। इसके साथ अब 2 की मल्टीप्लाई करते हैं, 18 आएगा तुम्हारा।
हाँ क्या नहीं ठीक है, क्या पता ये माइट बी कोइंसिडेंस भी हो सकता है।
कोइंसिडेंस नहीं, कोई कुछ सोचो तुम।
अपने
फर्स्टली हमें जो आर्यभट्ट थे उनने हमें अप्रोक्सीमेट वैल्यू ऑफ पाई बताई थी, तो उनने हमें ये बताया था कि पाई इज स्टैंडर्ड रेशियो बिटवीन सर्कमफ्रेंस ऑफ द सर्कल टू डायमीटर ऑफ द सर्कल। तभी तो श्रीनिवास बाहर से हमने करियो, हम कंट्रीब्यूशन ऑफ इंडियन मैथमेटिक्स डिस्प्ले करें। रामानुजन, आर्यभट्ट और
क्या क्या दिए हैं
उनमें क्या क्या चीज़ें इंक्लूड की हैं आपने?
उसमें आर्यभट्ट में तो एक तो पाई की वैल्यू, एक आर्यभट्ट की बुक में जो आर्य सिद्धांत थी उन्होंने ट्रिग्नोमेट्री फंक्शंस के बारे में बताया था, जिसके द्वारा स्पेस ट्रैवल में डिस्टेंस स्पेस टाइम हम कैलकुलेट कर पाए। उनकी वजह से ही अपने एक रॉकेट का नाम था भास्कर वन। और इस स्क्वायर में आप कहीं से भी कैसे भी सम कर लो, सब सेम आएगा, चाहे वर्टिकल कर लो, चाहे हॉरिजॉन्टल कर लो, चाहे डायरेक्टल कर लो, चाहे एंड वाले चाहे ले लो, सबका सेम आएगा सब
डायगोनली रो वाइज
वैसे। और ये आप डेट ऑफ बर्थ से बना सकते हो, वो हमने फॉर्मूला दिया था जो कि उन्होंने ये माधुरी
इन रियल लाइफ यू कैन सी दैट।
gave the formula to find the area of cycle
हाइट पे होते हैं या ऊपर होते हैं,
t minus
उनकी हाइट निकालना ना इजी नहीं है। ओवरऑल हमें ये भी नहीं पता होता है कि हम
t is
एंगल
the semi perimeter of the body length and PQRS on the sides. He also told the shape of the wheel and also calculated the circumference of the
यहाँ भी तो क्लियर आ रहा
36,000.
है, ये चल रहा है ना, आप इस सिस्टम पे देख लो ना, मैं भी
नहीं, इसका भी बहुत क्लियर आ रहा है, तभी ये ओपन हाउस में डल रहा है।
इसके लिए that is
ओपन हाउस ओपन हाउस में सर वहाँ पे वाईफाई डिस्कनेक्ट हो रहा था, इसलिए एक दो तीन चार बार कनेक्ट हो रहा था।
अगले क्वेश्चन में क्या करते हैं आप
यहाँ पे एक ऑप्टिकल इल्यूजन है, ठीक है। इसके अंदर जब हम 2D शेप को रैपिडली रोटेट करते हैं तो वो 3D शेप की तरह दिखती है, ठीक है। जैसे हम अगर रेक्टेंगल हम अगर रैपिडली रोटेट करते हैं, इट विल लुक लाइक सिलेंडर या ऐसे क्या इनका है। अगर सेमी सर्कल रैपिडली रोटेट करते हैं, इट विल लुक लाइक हेमिस्फीयर। ट्रायंगल को कोन एंड सर्कल को रैपिडली रोटेट करते हैं तो स्फीयर। थैंक यू।
हाय, क्या कर रहे हैं आप? ये एप्लीकेशन ऑफ ट्रिग्नोमेट्री है। जैसे बच्चों को बोरिंग लगता है ना बुक से पढ़ना, तो ये प्रैक्टिकली हम शो करेंगे। जैसे इसके अंदर से पहले एंगल मेजरमेंट हो जाएगा। अगर हम यहाँ से मेजर करें तो ये 30 डिग्री का है, बट अगर हम आगे जा रहे हैं तो हमें ये डिस्टेंस और फिर ये एंगल मेजर करके जैसे थीटा फाइंड कर रहे हैं, ये 60 डिग्री है तो tan 60 लगा लीजिए, ये x और tan 60 की वैल्यू लेकर फिर ये निकालेंगे। सिमिलरली यहाँ पे प्रैक्टिकली अप्लाई करेंगे। मान लो हमें इसकी हाइट देखनी है, यहाँ से हम इसको ऑन करेंगे और ये मेजर कर लेंगे इसकी हाइट, दैट इज़ 30 सेंटीमीटर। और फिर जो हमारा टेंजेंट है, टेंजेंट जो है हमारा वो 45 है, टेंजेंट 45 इज इक्वल्स टू 1 और फिर हाइट बाय परपेंडिकुलर करके इसको फाइंड कर देंगे। बट आपने यहाँ हाइट की जगह तो आई थिंक हाइपोटेन्यूज फाइंड आउट किया।
हाइट नहीं, ये वाला डिस्टेंस मेजर करेंगे जो बेस है, देन वी विल फाइंड द हाइट बाय परपेंडिकुलर यूजिंग tan परपेंडिकुलर। This setup shows an experimental setup involving two mirrors placed at an angle with protector beneath them. This setup demonstrates the angle of measurement and symmetry. When two mirrors are placed at an angle, multiple images are formed. The protector is used to measure the angle between the two mirrors and the reflecting object, applying the concept of degree and rotating symmetry. When two mirrors are placed at an angle, then number of images are formed. Let us take an object between these two mirrors and the angle between them is 90 degrees. Then we can see that 3 images are formed. If we increase the angle between these two mirrors 90 to 120 degrees, the number of images formed are 2. And if we decrease the angle between these two mirrors from 120 to 60 degrees, the number of images formed are 5. Hence, we conclude that as we increase the angle between these two mirrors, the number of images formed decreases. And if we decrease the angle between these two mirrors, the number of images formed increases. In this, we use the concept of symmetry and angles. The illusion of variation in image can be generated by using the mathematical formula n equal to 360 degree divided by theta minus 1, where n be the number of images and theta be the angle between the two mirrors. This model demonstrates symmetric and geometric transformation. We can see in this box, from one angle the object looks like a cube. If we see from the another angle, it looks like a rotatory cube. This is due to the phenomena of mathematical illusion. A mathematical illusion is the difference between virtual reality and what our brain perceives. Its real-life examples are: it is used in periscope, architecture design, and advanced holography. Thank you.
पहले करवाया था ना ये आपको जब एक्सिस के चारों तरफ एक जनरेटर को रोटेट करवाएंगे तो हमें इस प्रकार की दो कॉनिकल शेप देखने को मिलेगी, एक अपर नेपी एक लोअर नेपी। जब हम इन नेपीज को एक प्लेन के साथ कट करेंगे तो हमें 4 प्रकार के डिफरेंट सेक्शंस देखने को मिलेंगे, जिसमें हम पहले नंबर पर सर्कल, एक सर्कल को ड्रॉ करने के लिए एक फिक्स पॉइंट और एक फिक्स लाइन की जरूरत पड़ेगी। फिक्स पॉइंट सेंटर और फिक्स लाइन हमारी रेडियस कहलाएगी। नेक्स्ट इलिप्स ड्रॉ करने के लिए दो फिक्स पॉइंट के बीच की दूरी का सम कांस्टेंट होगा तो हम एक इलिप्स ड्रॉ कर सकते हैं। इसमें नेक्स्ट जो हमारा पार्ट है पैराबोला, ये वाई एक्सिस के अलोन मैंने एक पैराबोला बनाया है। एक पैराबोला बनाने के लिए एक फिक्स पॉइंट और एक फिक्स लाइन, फिक्स पॉइंट हमारा फोकस और फिक्स लाइन हमारी डायरेक्शन होगी। इसमें बहुत से एग्जांपल दिए, हमारे डिश एंटीना और रेनबो सेंटर। नेक्स्ट हमारा हाइपरबोला, हाइपरबोला बनाने के लिए दो फिक्स पॉइंट के बीच की दूरी का डिफरेंस कांस्टेंट होगा तो हम एक हाइपरबोला ड्रॉ कर सकते हैं। इसके वेरियस एग्जांपल जैसे न्यूक्लियर कूलिंग प्लांट में हम इस टाइप की एक शेप न्यूक्लियर कूलिंग प्लांट जो हमें ये शेप देखने को मिलती है, टेबल लैम्प गिटार डिफरेंट इस एंगल पर
ये आपने कटिंग के लिए शो करा था।
ये सर्कल है पैराबोला।
टॉपिक पर बना अपना प्रोजेक्ट।
Our mathematical project is based on roller coaster. The maths used in roller coaster. Roller coaster for both safety and predictability uses mathematical concepts and polynomials and calculus. Polynomials are used to determine the slopes and the soft paths for hill and safety. A section of a roller coaster can be written in an equation: y equals to ax cubed plus bx squared plus c plus d, where ABCDs are the coefficients which will control the steepness and curvature and shape.
Basically, roller coaster is a machine that uses gravity and inertia to send a train of cars along the winning track, and where the combination of gravity and inertia along with acceleration gives body some certain sensations.
Calculus is used to design curves, loops, and twists in the roller coaster, which provide both safety and excitement to the people while enjoying the ride.
Trigonometric functions like sine and cosine are used to create loops and wave-like curves, and also they will help in measuring heights for safety.
आपका एम क्या है मेनली इसका?
It's about the real-life application of maths. Everywhere, maths is everywhere.
मतलब बेसिकली आपने रोलर कोस्टर में मैथ्स कैसे यूज़ होता है ये दिखाया है। इंटरेस्टिंग, यूनिक है अब तक का।
Here we have a mathematical part. Here we can apply a trigonometric concept to measure this height, and we have this base which is equal to 26 centimeters, which is equal to 26 centimeters, and this angle is 60 degrees, and we can calculate this height easily.
And as we increase the height, the angle of elevation is also increased, as you see here. Here we have some formula of sin theta is equals to perpendicular by hypotenuse, cos theta is equals to base upon perpendicular, tangent theta is equals to perpendicular by base. As in this hexagon we see the relation between sine is reciprocal of cosecant and cos is reciprocal of secant and tangent is reciprocal of cot and cotangent.
Here we have a sine height, which is required to learn the trigonometric values, and here we have a sign convention of trigonometric functions. Some mnemonics are required to learn things easily, so we have a mnemonic add sugar to coffee, and here we have graph of sine, and this one is the graph of cosine.
मैथमेटिक्स पार्क का गेट अच्छा है. क्या है आपके प्रोजेक्ट का?
It's a trigonometric park representing all the play toys and different things in terms of trigonometry. First we have the circular player which is representing Pythagoras theorem. Then we have this exercising machine representing trigonometric functions with all their values. Now here it's a working model to know the height of the street light. And after this we have a watching tower for us, making us know the reciprocal identities for different trigonometric functions. And this slide is there to represent the trigonometric formulas. That is sine theta is equal to perpendicular upon hypotenuse. Now talking about this, it is super hexagon, which is easy for us, which makes easy for us to remember the trigonometric formulas.
What about this one?
Okay, yes, this is a seesaw representing two different angles. One is angle of elevation and the other is angle of depression.
बेसिकली आप ट्रिग्नोमेट्री का यूज़ करके दैट्स सो इंटरेस्टिंग. ये सीजो वाला अब तक किसी ने नहीं किया है.
मैम ये पाइथागोरस थ्योरम. हाय एवरीवन. ये ए स्क्वायर है, ये बी स्क्वायर है, ये सी स्क्वायर है. ये स्क्वायर प्लस बी स्क्वायर इज इक्वल टू सी स्क्वायर. और जो ये ए स्क्वायर है ये बेस है, बी स्क्वायर है परपेंडिकुलर और सी स्क्वायर है हाइपोटेन्यूज. ये पाइथागोरस थ्योरम सॉल्व है.
ये मैम ट्रिग्नोमेट्रिक टेबल है. इसमें हमारे साइन थीटा और कोस थीटा की वैल्यू उनके डिग्री के हिसाब से उनकी वैल्यूज बताई गई हैं सर. इसमें सर जैसे साइन थीटा की 45 पे होती है 1/√2, तो इन सभी की वैल्यूज बताई गई है.
और इसमें सर जैसे 1/cot इज इक्वल टू tan थीटा होता है. तो ये बता रहे इसका रेसिप्रोकल रेशियो बता रखा है इसके अंदर.
बेसिकली फार्मूलाज डिफाइन कर रहे हैं. आउटकम 8 है. इसमें हम कोई बात नहीं आ गया तो 1/8 होगा. इसमें हम कॉम्प्लीमेंट्री इवेंट भी निकाल सकते हैं. जैसे इवन नंबर ले लेंगे और ऑड नंबर ले लेंगे, उनको प्लस करेंगे तो 1 आ जाएगा. इवन और 4 है और भी
मैंने फिबोनाची सीरीज पे प्रोजेक्ट बनाया है. ये सीरीज लास्ट के 2 नंबर का सम करके अगला नंबर बनाती है. जैसे हमने देखा 0 + 1 = 1, 1 + 1 = 2 एंड सो ऑन. ये हमें कई नेचर की चीज़ों में देखने को मिलती है. जैसे फ्लावर पेटल हो गए, वो जैसे इसमें 3 हैं, इसमें 5 हैं, इसमें 55 हैं, इसमें 89 हैं. और जैसे हम इसको प्लॉट करें तो ये हमें कई चीज़ों में देखने को मिलती है. जैसे जो टोर्नेडो फॉर्मेशन होता है, गैलेक्सी होती है, सी शेल होती है, जैसे हम इस शंख में भी देखें तो इसका जो स्पाइरल है वो इससे साथ रिजेंबल करता है. एंड अगर हम हाथ की भी फॉर्मेशन देखें तो जो फिंगर बोन होती हैं उनके जो लेंथ का रेशियो है वो हमें 1:2 में देखने को मिलता है अप्रोक्सीमेटली, और जो कि हमारे इस सीरीज़ में भी देखने को मिलता है. इसकी वैसे तो खोज इंडिया में हुई थी, पर वेस्टर्न वर्ल्ड में इसे फिबोनाची जिन्हें लियोनार्डो ऑफ पीसा भी कहते हैं. बोले थैंक यू. इनके किए हैं, इसके लिए इसके भी किए हैं.
रियल लाइफ एप्लीकेशंस है.
क्या किया आपके प्रोजेक्ट में?
2D एंड 3D शेप्स के बारे में बताया गया है. इसमें 2D एंड 3D शेप्स के बारे में बताया गया है. 2D शेप्स जो होती है
उनके अंदर सिर्फ हमें लेंथ और ब्रेथ मिलती है। अगर उन्हें थोड़ी सी भी हाइट प्रोवाइड की जाती है तो वो 3D शेप्स में आ जाती है। इसके अंदर हमने एक स्पिनर बनाया है जिसको आप स्पिन करोगे तो शेप के आगे उनके नाम डिस्प्ले होंगे। और ये इधर हमने 3D ज्योमेट्री के ऊपर बनाया है जिसमें 3D शेप्स आपको डिस्प्ले कर रखे हैं। और अगर आप इसको ओपन कर रहे हो तो आपको वॉल्यूम का फॉर्मूला दिख रहा है। ये यहाँ पे हमने टोटल सरफेस एरिया, लेटर सरफेस एरिया और वॉल्यूम के बारे में बताया है और इसमें एरिया के बारे में बताया है।
बंद कर दूँ?
कर लिया ना, बस अब एक बार कर लें, अभी है ना, स्टॉप कर दे, कोई बात
सर या पानी में
चलो ये पड़ेगी बात थोड़ा ये सोचिए हम जैसे गधों की तरह लग रहे हैं
बैटरी लो तो इस चार्ज करने के लिए हम इस टाइप के स्टेशन बना सकते हैं। जैसे हम स्विच ऑन करेंगे ना, इसके अंदर ये ग्लो कर रहा होगा, तो इसके नीचे एक कॉयल है, कॉपर कॉयल,
मतलब एक वायर को बाउंड करके ना, जैसे इसमें दिख रही होगी आपको, वैसे ही इसके नीचे डाली गई है, उसको सप्लाई से कनेक्ट कर दिया गया। तो सप्लाई से जैसे कनेक्ट करेंगे उस कोयल के अंदर अगर करंट पास होगा ना तो उसमें मैग्नेटिक फील्ड बनेगा, और जब ये कोयल मैग्नेटिक फील्ड की प्रेजेंस में आएगी तो इसमें करंट इंड्यूस होगा। हाँ, फिर वो चार्ज होगा। ट्रांसफॉर्मर जिस पे बेस होता है ना क्या राहुल?
हाँ ये वही लगा गया सर, हमने बेस पर तैयार किया।
हाँ, चलेगा क्या?
सर जब वाटर सप्लाई होगा तब इसमें बैटरी स्टोर होगी ना, वाटर सप्लाई हो नहीं रहा।
हाँ,
नहीं अकेले का तो नहीं है अभी, और लेकिन चले गए घूम रहे हैं बाद में।
उसको देख लो, फोकस देख लो।
इसको पकड़ मैं देखता हूँ, इसको पकड़ मैं देखता हूँ। ये कहाँ देवा तुम खाली एरिया में। ठीक है।
यही है।
अरे उनकी टाइम ड्राइव से होगा, इससे नहीं होगा, लोड नहीं होगा, इसी पे चला देना उसको करके दोबारा ले लो। वो डाउनलोड हुआ नहीं, उससे पहले नहीं निकाल एक और लगाओ, डाउनलोड हुआ नहीं। इसको देखो, कैसे चल गई इसको, उसमें खोलना है, ऐसे तो वैसे ही चल रही और PDF एडोब में खोलना बेटा, राइट क्लिक कर दे।
वो आप खींचनी है
क्या
फोटो?
हाँ खींचनी तो है। लक्ष्य को बाकी मैंने बोल दिया, लक्ष्य को मिले तो देखियो।
ये लो आ गए।
अरे तो वो अपनी फ़ोटो खींच रहे हैं ना, लक्ष्य को देखियो।
तेरे पास एडोब नहीं है?
Good afternoon, one and all. Esteemed Director, Professor Vijay Kumar Behra ji. Guest of honor for this occasion, Professor S. Dharmaraj. Renowned mathematician, Sri Gulshan Kharbanda ji. Principal, Halwasia Vidya Vihar, Sri Vimlesh Share ji. It's my pleasure to welcome you all to this workshop on mathematics. Before I formally invite the resource person for this workshop, Professor S. Dharmaraja, let me present a brief introduction. Professor Dharmaraja earned his BSc degree in mathematics from Presidency College, Chennai, Madras during those days in 1992. His Masters of Science in Applied Mathematics from the prestigious Anna University, College of Engineering, Guindy, in 1994. He earned his PhD in Mathematics from the Indian Institute of Technology, Madras, in 1999. From 1999 to 2002, he was a postdoctoral fellow at the Department of Electrical and Computer Engineering at the Duke University, United States of America. From 2002 to 2003, he was a research associate at the TR Labs, Winnipeg, Canada. He has been with the Department of Mathematics, Indian Institute of Technology, Delhi since 2003, where he is currently a professor. He is also the joint faculty of Bharati School of Telecommunication Technology and Management, June 2013 onwards. He is a professor from October 2020, and he is appointed as Institute Chair Professor from July 2019 to 2024. During September 2020 and August 2022, July 2014 and August 2017, he served as Head Department of Mathematics. He is also appointed as Jaswinder and Tarvinder Chadha Chair Professor for Teaching and Research in the area of Operation Research from May 2010 to 2015 July. He has held visiting positions at the University of New York, USA, Duke University, USA, Emory University, USA, University of Calgary, Canada, University of Los Andes, Bogota, Colombia, National University of Colombia, Bogota, University of Verona, Italy, San Juan University, Suwon, Korea, Università de Studi de Salmano, Fisciano, Italy, and University of South Wales, Sydney, Australia. Professor Dharmaraja's research interests include applied probability, queuing theory, stochastic modeling, performance analysis of computer and communication systems, financial mathematics. He has published over 100 papers in refereed international journals and over 40 papers in refereed international conferences in these areas. Professor Dharmaraja is also an associate editor of International Journal of Communication Systems, published by Wiley, and an associate editor of Upsearch, published by Springer. He is co-author of a textbook called Introduction to Probability and Stochastic Process with Applications in John Wiley, the US edition. And he's also a co-author of the textbook entitled Financial Mathematics, an Introduction in Narosa, November 2012, and co-author of another textbook called Introduction to Statistical Methods, Design Experiments and Statistical Quality Control in Springer. Recently, he has also authored a monograph as a co-author, that is Reliability Assessment of Tethered High Altitude and Unmanned Telecommunication Platforms. We are indeed honored to have such a distinguished scholar among us. Without much ado, I invite Professor Dharmaraja. Sir, please.
So good afternoon to all. So first I should thank Professor Baira to giving this opportunity. Can I use that one? That may be easy. Is this one? Fine. So first I should thank Professor Baira for this opportunity. And traveling all the way from Delhi to here in the morning. The weather also is nice today. And I am interested to tell what are all my experience with mathematics that will motivate the students to do mathematics and do the things for our nation. That's what I am coming to. And I always I just walk always. I cannot stand one place and give a talk. So I feel when we spend 1 or 2 hours with the students, at least if we motivate 1 or 2 students, I think that is worthwhile. And still there are many more seats in the front. So if you think that you can backbencher, then I will also be a backbencher all the way coming here and speaking. Instead of use the only podium and stand there. I don't have that habit. Okay. And I treat this as my lecture class. That's the way I teach. And if the class is at 9 o'clock, I am there 8:50 itself in the hall. And keep the things ready. And I am the first guy in the classroom. And I start the class on time. And I keep asking professor what time I should start, I so N2 and so on. So he was telling whenever it is ready, then he will call me. But still, 1 hour or 45 minutes speech. Of course, I am going to talk about what I did. It may be a little show off, but that is the way we should do the show off so that will motivate you to come to the mathematics and do the many things. Right? And as I said, I am from nearer to Kanyakumari. My place is a very small village, and we have 3 times a bus. Morning 1 time it comes, and lunch and evening. That's all. So if you miss the bus, then there is no connectivity from our village to the neighbor within some 5 to 10 kilometers itself. So that is the place I born, and I have done my schooling till 7th standard in that village. Then we moved to Chennai, and in Chennai I did remaining schooling, then SC Mathematics, then MSc Applied Mathematics, then PhD Mathematics, all in one road that we call it as a beach road in Chennai, and 10 years continuous studies, BSc 3 years, 2 years MSc, then 5 years PhD. After my PhD in mathematics, usually IIT Madras PhD, they go to the postdoc in Israel or Europe in mathematics department, some university. I also applied a postdoc in a different place. The day I got the offer, I asked my friend, where is this place? Because I didn't bother about place and all. I was keep on applying the postdoc. So after I got the offer, I asked my friend who is helping me where it is. Then my friend, she was telling it is the east coast of USA. That is called North Carolina. The university name is Duke University. So I went there as a postdoc in electrical engineering department. I am the first guy went from maths department to the electrical engineering department as a postdoc. I enjoyed there, and my first job was my prof was asking me, listen, if you guys are not listening, then ask you to get up and come and sit down in the front desk. Okay. Even if anybody speaks for more than 1 minute, not listening to my talk, then I can immediately make out. Okay. I am coming all the way from Delhi to here to speak with you guys, at least to listen something. When you go home, you should know why you came here. If you are keep speaking with some of your friends and so on, you can get up, go out and talk with them. There are many spaces. There is a minimum ethic level, how to respect the hall. Okay? How to respect the teachers who are in the front, how to respect the others. If I don't want to respect you, I can just go to the podium and keep on pressing all the slides. I can speak myself and say that my talk is over. Chalo. I'm not the guy. Okay? So I'm coming all the way back to make you to listen, because you think that backbench me you can do whatever you like, not the front bench wallahs. Okay? So I'm here to take care of you. Where I stopped it? Bataiye, where I stopped it? Yes, bataiye. Where I stopped it? What I said last? I'm asking you. Where I stopped it? You remember? What was the story I said where I stopped it? Yeah, where? Any word? Correct. So you listen something. So I stopped it. I went as a postdoc in Duke University, North Carolina. The first job my prof has given to me to write the proposal on reliability analysis of spacecraft systems. To write the project on reliability analysis of spacecraft system. I don't know what is a spacecraft itself. The day he told me to do the job, I don't know what is that. I started reading. Every week there is a one-on-one meeting with the professor and we have to give a progress. So I was keep on preparing the proposal. I showed the first draft to him. He said, okay, you understood a little bit, you improve it. So I was keep on improving the draft. From the web I understood what is a spacecraft. Spacecraft ka andar kya hai, and what is the meaning of reliability, and why reliability has to be studied. Everything I learned it myself with the asking my friends some doubts. Then we wrote the proposal, submitted, got the project, and the professor asked me to work on that same project. I worked on that project for 3 years. It's a NASA project. And the NASA has given the project to the different universities. Before the spacecraft is prepared, the NASA has given a project to the universities to study the reliability analysis of spacecraft before it is making. That means before making, you should do the complete analysis mathematically and give up with the report. If you launch it this time, if you keep this many components inside, then it will run this much time. Telling in a very easy way. If you this component inside the spacecraft, if you launch it in this way, it will run for this much time. Before you born, Amara country mein, whenever the spacecraft launched, you see it in the radio news and now the TV has come. So we keep listening the news. It says launched in Sriharihota. You know the place called Sriharihota? Yeah, some people know that. That's good. After the launch, the second day it says it's got failed. It's crashed into the sea. Therefore, that spacecraft is waste. That was the news 20 years back. But if you see current technology, whatever we are launching, it is going to the orbit, the Earth orbit, and it is going smoothly not only going smoothly, whatever the time it was planned, it is going more than that. Suppose it is estimated for 6 months or 1 year to run around the earth and gives the signal to us and so on. It gives more than that. That means इतना improvement हमारा country में ISRO has put all the effort to make it, and it is running. So we should be proud of how much technology we have improved it over the days. So I was part of that project. With that limited knowledge, I came all the way to Delhi as a faculty in 2003, and my 22 years are over. And I know Professor the day I joined. From 2004 onwards, I know, because his daughter, at the age of maybe 7 or around 10, and myself was the batchmate in the Bharatanatyam class. After joining IIT faculty, 2003, 2004 onwards, I joined in the Bharatanatyam dance school, and I spent 5 years of learning Bharatanatyam. So I got a diploma in Bharatanatyam at the end of 2009 or 10, along with the professor's daughter. So that is the way I know Professor, who is a director of this institute. So other than studies, I enjoy the dance also. And I treat all of you as the audience of my dance class or whatever it is. And being the performer, I know how to have a one-to-one contact with everybody. I know one-to-one contact with everybody in all the audience, whoever is about to sleep, whoever is I am making make sleep more, and who is listening, who is able to say whatever I say, the next word they are able to pronounce from their lips. That much I am accurate. In my IIT Delhi class, the class of 500 capacity hall, and the class is full of 400 or 450 students. Even any one student is using the mobile, typing anything, I can make out. So that much I am sure. Got it? Got it? Yeah. So I am got it at every eye-to-eye contact with every student or every audience, so that they cannot leave me thinking that I am doing something and you are doing something and we are mentally in the different world. See, a good speaker should have a one-to-one correspondence with all the audience. Then it is good for the lecture as well as the any talk. That's the way I feel. By the way, I prepared around 20 to 30 slides. I am not going to show all the slides to you. I am going to show 1 or 2 slides to just say that what I have done and how I can motivate you to do mathematics or any science and technology. And this title is given by your Microsoft, Role of Mathematics in Science and Technology. Then immediately I typed it. Then I prepared the slides. I am going to show only few slides out of the slides which I prepared. Go to the next slide. Yeah. So I'll keep asking how much time I should speak so that you will be ready to listen more and so on. He said you take 45 minutes. So already I finished 15 minutes. So in that 30 minutes I am going to tell what else I have done with the slide. Fine. So I want to tell a few things about the Srinivasa Ramanujan because of the National Mathematics Day, and then I am going to talk about a few reliability work which I have done for our country after coming to India. So these are all the different
स्क्रीन प्लस बच्चों की फोटो इस टाइप से करके कैमरा पे आपको
उठा ले।
अरे पक्ष कितने ऑप्शन था 555 नंबर ऑप्शन कौन सा था 7 का 7 का कौन सा
दो की पावर 6 करता है चौसठ में कोई बात नहीं नंबर
पावर 9 है, बल की पावर
हो सकता है मेरा मैंने तो अभी किया है मैंने कर ले थोड़ी देर और कैप्चर कर ले
उधर पोस्टर मेकिंग वाले का हो गया
हाँ करके आया
एग्जाम दिए थे
इसको एक बार लगा देते हैं, पर नहीं तो बॉडी में कहाँ रखना, राहुल को तो पूछो।
Hello? It was many ladies. He was using his own way of writing. Few days we write a perfect bracketed. That means we know that we said we have to use the letter. For him, whatever he is doing is built up, we could say, and he improved the number theory concept, which is worldwide. People are working on it, but for him it is just writing. He never seen such a books. He had never seen such articles. He never gone through how the proof has come, but he has all the proof by himself, just like that. That means that's the inborn genius. He didn't need any education, or he did not any trained one. He didn't do that, but he himself was doing everything. And another good thing is how many of you know about the value of pi? Raise the hand. How many of you know the value of pi? Now you can go and read the Google Mail, the story about the pi. The value of pi, he wrote it in his notebook. It was keep on going. 3 point. Whatever the number we have it, it is always truncated somewhere. But the numbers which he has written after the 3 point, all the decimals, he was keep on writing. It goes many pages because he has the idea what is the next number, what is the next number. So his brain already that algorithm was there, and he was keep on writing. Still, to match how many decimals he wrote it with the supercomputer or writing an algorithm in a nice way. Still, people are not matched how many decimals he wrote it and the computer algorithm or whatever the way we made it. We didn't match that. The decimals he wrote it, we didn't come to that level. That means you think how much accurate his brain algorithm it works, and he keep writing all the decimals, which as on today also the computer is not matched with all the decimals he has made it by his brain. That means you compare how much he is knowledgeable with the numbers. Even people say, go to the next picture. Even people say he has a fond of friendship with many numbers. Whatever the number you say, he will say uska story he will make it. That means he has the information about every number. I'm going to tell about one number. Yes. So this is a famous number. How many of you know this number? Good. Yeah, good to see the students who have interest or knowing about that. 1729. The 1729 ka story, it is written. If you read, you will understand. I don't want to repeat the whole story, whatever it is written. But like that, he has fond of many numbers. This is one such number. If you tell any number to him, he will tell the story for that number. That means you think how much is passion about the numbers. In the same Ramanujan Museum, what we are doing in my BSc days, we do the fun mathematics class every Sunday 10 to 12. I was assisting that person. Our job was call the nearby kids from 1st standard to 8th standard kids, calling them and make a fun mathematics in that Ramanujan Museum in every Sunday 10 to 12. And fun mathematics means we make them different things connect with mathematics. For example, one such game is you tell about one anything. One में क्या क्या है? One head. क्या और one में है? Then after that, Number 2. 2 में क्या है? 2 eyes. 2. Like that you should keep on telling. Then 3. Then 4. Then 5. Now you think 10 में क्या है? Immediately you can make out. Then 11 में क्या है? Then you will be stuck. So like that your thinking power will be keep on improving with the different numbers. What is 12? What is 13? You can tell about 13 May, Jesus ka story, or 14 ka another, 15 ka another, 16, like that. Different numbers ka, we'll ask them to story and we make so many chota games and we make them numbers may how many things you can play and one box ka under you can put how you can teach the volume. So many things we do it in the fun mathematics. So I am fond of that, doing that job. So I am more of one-to-one contact with the students and making them to learn mathematics, my BSc days itself, as a evening or doing this type of duties. Yes, so I want to show, this is the Ramanujan Museum, if at all you go to Chennai, and if you put a Google, you will find it the same thing. So here there all his letters are there, what he wrote, and what he was telling to his mom, how much he was having experience with England, and still he was eating rice and making chawal and all those things and eating, and how his eating habit there, and how much weather was affecting him during his stay in England, and how much he is managed with the new people. Only common thing is his knowledge, his mathematics. Other than mathematics, everything is new to him, but still he survived. And whatever he has done the work, he made it. People made it as a lost book, and still people are doing research over that book. Still, it is research is going on. Whatever he has done. So the people who are interested in number 3, one day you will come to know how much Ramanujan's knowledge you are able to reach his level. Right? These are all my different projects. In one project I was studying how the network is connected in the whole country. Whenever you speak, your call is going to the different place and you other side people are listening. You may think that just you are listening, but inside the whole country, under the ground, there is a big network. So the network means it's a wired network from here every. So how that network works? Being a mathematician, I abstracted that if any one component fails, then how to repair it and how to connect it. If one path is not working, then how you make another path. Suppose somebody is calling from Jammu to Kanyakumari, whether the call has to go via Mumbai or via Hyderabad, or it can go to Calcutta, or it can go to Visakhapatnam and then down. These are all the paths. So how different network works and how the dynamics goes. So using probability, we study everything mathematically, then we understand, then we make the results, then we come up with the idea. Even for example, suppose there may a crore tower you want to make it. How much bandwidth you should put it? Suppose I make a less bandwidth, whether your call will be connected or not. What is the loss probability? What is the call blocking probability? Or what is the throughput? There are many more jargons which is related to the network, which we understand and make the model and get the result, analyze, complete the project, give the report, and based on the report, you want the recent 5G implementation. I am also part of the 5G implementation team. When Modi ji was launching the 5G that day, we are also part of it in the background, because that 5G project is given to us, including IIT Delhi, few more IITs. Before 5G you are using, we prepared a complete study and made a report and give it to the government. This is the way the 5G has to be operated. So after our report is submitted, then the actual implementation started and so on. Then the 5G is given to the country. So I was also part of the 5G implementation team. My work was whenever you use the mobile, when you didn't use the mobile for some time, the mobile goes to sleep mode. The way when I am speaking very boring, you go to the sleep mode. And when I speak more boring, you will go to long sleep. First you have a short sleep, then you go to the long sleep. The same way, if you are not using the mobile for a few microseconds, some components goes to slow sleep. If a few more seconds, if your mobile you are not using, then that goes to another short sleep. So it goes for few short sleeps. Then if you didn't use mobile for a minute, then it goes to long sleep. Then it will be in the long sleep for some time. But still there is a few components will keep on beeping. Make sure that is there any call is coming or you are going to message or something. So I identified what are all the components should go to the short sleep, what are all the components should go to the long sleep, and how it should functioning, so that you can use the mobile for some more time. That's the optimization problem. The question is how you can use the mobile for longer period with a given charge, and how the mobile should go to the sleep. So even when ma'am is getting a message, before a few microseconds, one component in the mobile, it woke up and say that you are going to receive a call or you are going to receive a message. It is going to, that's called control channel. So we understand everything being a mathematician, but then we make the model and analyze, then we get the result, and then we go for inverse problem. Inverse means how to configure the system so that you can have that. First we study as it is, then we go for reverse. The way हमारा घर में एक और room चाहिए, same logic. Suppose you make a one more room, how it happened, then you actually go for it. The same way we go for, suppose you understand the system first, then we go for modification, then we study that, then we come to the conclusion, then back and forth we keep on improving. After we satisfy, then we go for it. So that's what I'm doing for many of the projects. Old one. Yeah, the one I said, short sleep, long sleep and all, this is the way we mathematically understand how the mobile goes to the sleep mode. And this I learned it from Korea. I went the way to Korea to understand. And when we are using the 3G, when we are using 3G, Korea is already working on 6G. Those guys are very fast, and they are always 2 or 3, at least 1 or 2 generation they are ahead doing the thing. I went there, I sat down with the professor from Korea, and I learned from him. For me it is a completely a new topic. Still I put the effort in one summer, I went there, I understand, and then came back, then I started doing research on this subject. Before that I don't have any idea. Till I went to Korea, I don't know about how to save the energy in the mobile. That I learned it from him. Yeah. Yes. ये क्या है बताइए? I'm overshooting by some more time. Yeah. बताइए, what is this? Any guess? Whatever you think, बताइए. What it looks like? Looks like? Oh, because my abstract diagram was too abstract, therefore you are not able to make out. If I would have made an actual diagram, then immediately you will tell this is what this. Yes. But ये क्या है? ऊपर क्या है? ठीक है. Any some more guess? It's a satellite. Okay. Any other name? Any other name? Any other name? Can we say balloon? It looks like balloon. It's called air balloon. It's a very big balloon. So the balloon does the job of communication around that area. For example, suppose somewhere landsliding, somewhere earthquake, Vayanadu, or any disaster happen, then it can go in a vehicle, and the vehicle has a one balloon with half kilometer height. Then this balloon will be hanging with the wire, and itna height may it will take care of all the communication below some 2 or 5 kilometer radius. Yes, and I will finish it in 5 minutes, 5 or 10 minutes. 5 is fine. So I was working on this project with Russia, and Russia made this air balloon with the complete communication, and my job was to do the reliability analysis of this. So I was mathematically abstracting and understanding the system, then make the reliability model and got the result and show it to them, and they feed the parameter values, some data, and then I improve the things, and back and forth we are keep on improving. And I traveled to Moscow 2 times, and I have seen actually how it works, and the professor made a demo to me how it works also. Therefore, when I went there, I have seen the actual balloon, and balloon, or you can say drone also. It's a wired drone, and I made the reliability model for the same. So I was doing not only with the balloon, I am going below the satellite level also. So how the communication can be made in the below the satellite, then how we can understand that and make the model and analyze it and give the result and show the result to the people who propose the project. Then we give the result and so on. So I was back and forth understanding the things and make the model, then give the results to them. That's my task. Yeah, this is the one project which I was telling. This is our DRDO project. So here we are working on the reliability analysis of how to kill the drone whenever the drone was giving a trouble to us. Not all the drones. So that's a laser beam. And the problem is when you start shooting, if the environment is very bad, there is a possibility it will not hit the drone, then the drone will hit us. So therefore you have to be very smart enough. Even the drone goes whatever the position, the beam also should go in a correct time and it has to hit. If it is hit little later, there is a possibility of danger to you. So it's a very critical job, but still we have succeeded there. Other than this, I was doing many other stuff. For example, I was doing the prediction of corona wave 2 with the data of wave 1. That means as the corona keep going, I have a data of some time. I was able to predict another 3 months what is going to happen. So we make the mathematical model and we got the result. We make the diagram, we got the curve. Then we waited for till that time. Then we saw whatever we predicted 3 months back and whatever the graph which we got it on that day, we compared it. Then we did the error analysis. Error means what's the difference between what you predicted and what you got it. The difference is error. So we did the error analysis also. Then we come to the conclusion how much error was there and how much death is happening. That also we predicted. You know, whoever remember corona wave 1 and wave 2, that analysis also I have done. And other than that, I was doing prediction analysis for government. Whenever our government is spending money to different projects, different money to the different people, how much they should spend further years, or what is the optimal way they should do, therefore they can be a worthwhile planning. So I am in the planning section and helping government how much money you can spend for different things and what is the way you should go it. and also I am working on indigenous product also. How much our Indian product is improving over the days. So that prediction also I have done. Because after the Modi ji government, they are keep on making how much percentage we are improving our own Indian products, then buying from other country and using it. So we are reducing that and we are increasing our productivity. So that predictive analysis also I have done it for our government and I have given the report to them. So being a mathematics faculty, studied BSc Mathematics, MSc Mathematics and PhD Mathematics, I am worthwhile to our country of whatever the mathematics I learned it through the different projects. So I am helping or I am useful to the government as well as useful to the society with my mathematics knowledge. So with this, let me conclude my talk. Thank you. Any questions? Any questions?
Sir.
Any questions? क्या बताइए?
2 मिनट रोक लो बस, तो लंच के लिए जाएंगे. क्वेश्चन है नहीं करो, क्वेश्चन है नहीं सर.
Okay, so I always think you should have a passion, passion or interest. The second, you should have a proper time management, and the third, the hard work till the end. When my college days or the school days, I never fix time to sleep. I fix the time to finish this chapter or finish this much, then I go to sleep. Even sometimes I go to sleep 11 or 1 or 3 in the morning. So I never fix the time to sleep. But once I have a passion in it and I put all the time management and hard work till the end, I never give up. There is a word I got it from my cousin when he gives the book. The impossible one is which you never tried. The impossible thing which is you never tried. Negation. Whichever you tried, it is possible. That's the positive mindset I have it. Whatever the task I do, whatever the new task also I take it. One may I have a passion and then I make a time management, choose the time. Even in the Gaudi also I was keep doing something or choose the time. I never use the word I will do after this. No, I am good in parallel task. Parallel task means from morning to night I may do n number of things, partitioning my time into piece by piece. And never I use the word after this I will take up this job. No. Whenever I get the very limited time also, in the flight I usually set the question paper. In my flight, after takeoff, I take a 10-minute sleep. Then after the short sleep, immediately I open my laptop, cleaning my laptop or setting the question paper, whatever I want to do alone without internet. I do all the jobs in the flight. I write to my students, your question papers are made in heaven, thoda sa niche, AA 423, Delhi to Chennai flight. Or Chennai to this flight. That's the way I motivate the students. So I never wasted my time. That's what I am making you also. When you listen to my talk, you should not waste. That's what I make the people to go out. And whoever inside, I can have a one-to-one contact with everybody. Any other question? Any question? We should thank your director Saab, Baira Saab, making me to stand here. Thank you, sir. If you have any other questions, I can answer you outside also.
Thank you, Professor Dharmaraja, for this highly enriching lecture. There is no denying the fact that your lecture is beneficial. I'm not using the helping verb was, I'm using is deliberately, just in the sense that the thought process will continue. So your lecture is highly beneficial for teachers and students as well. Ladies and gentlemen, we have another distinguished mathematician with us, Dr. Sanjay Goyal. Let me introduce him. Dr. Sanjay Goyal is presently serving the Vash College Bhiwani as its principal. With his experience of over 35 years, Dr. Goyal has contributed immensely to the domain of research in the form of research articles, workshops, conferences and seminars. The Department of Higher Education, Government of Haryana recognized his contribution in socio-economic survey and honored him with a special prize, and he led his college to the first position in state economic survey. Dr. Goyal has also edited various journals, and as an author he has penned 13 books. We are indeed honored to have you here, sir. May I request our senior most lady faculty, Dr. Amandeep Kaur, to please come forward and present a bouquet. Ma'am, please. Thank you so much, Dr. Amandeep Kaur. We also have Sri Kapil Sharma ji, another mathematician with us. Mr. Kapil Sharma is serving Bhiwani district as district mathematics specialist. With his experience over 15 years, Mr. Sharma has contributed to the domain of education in mathematics tremendously. We are indeed honored to have you here, sir. May I request Dr. Mukesh Kumar, HOD Electronics and Communication, to please present a bouquet. May I now request Director Professor B.K. Behra to please present a memento, a Samman Pattika and a token of hospitality to our guest of honor, Professor S. Dharmaraja. Thank you so much, sir. Ladies and gentlemen, as we declared in the morning, that this year, as a part of the celebration of the National Mathematics Day, we are presenting Lifetime Achievement Award to 5 distinguished mathematics teachers for their contribution to education in general and mathematics in particular. I would request our guest of honor, Professor S. Dharmaraj, and our worthy director, Professor B.K. Behra, to please felicitate Dr. Sanjay Goyal. So please. No, individually. Ladies and gentlemen, this Lifetime Achievement Award is presented to Dr. Sanjay Goyal, Principal, West College, Bhiwani, for his contribution to the field of education in general and mathematics in particular. May I request Dr. Anil Sachdeva to please come to the podium. He wanted to say something, so please.
गुड आफ्टरनून। मैं संजय गोयल सर के बारे में कुछ कहना चाहूँगा। सर, मेरी वाइफ मैथमेटिक्स में है और संजय गोयल सर की स्टूडेंट रही है, और मैं 3 दिन पहले बात कर रहा था कि संजय गोयल सर को हम जो है सम्मानित करने जा रहे हैं, तो बड़ी खुश हुई। तो उन्होंने एक बात बताई कि हम किसी भी टीचर की क्लास छोड़ सकते थे, लेकिन जब संजय गोयल सर की क्लास आती थी ना, पूरे के पूरे स्टूडेंट उस क्लास में प्रेजेंट होते थे। और एक वाकया उन्होंने बताया कि मैम स्कॉलर रही है, मतलब टॉपर रही है वेस्ट कॉलेज की उस टाइम की, और एक दिन वो क्लास उन्होंने मिस कर दी। नेक्स्ट डे सर ने बोला कि तुम क्लास में कल नहीं आई थी। मतलब सर का इतना ऑब्जर्वेशन है कि एक एक बच्चे का ध्यान रखते हैं कि कौन क्लास में आया और कौन क्लास में नहीं आया। ऐसे है हमारे संजय गोयल सर।
Thank you so much, Dr. Sachdeva. May I again request Professor Behra and Professor Dharmaraja to please felicitate again one of our senior mathematicians, Sri Asutosh Sharma ji, with a memento and a Samman Pattika and a token of hospitality. May I now request, sir, please continue. 3 more to go. May I now call upon senior mathematician Sri Gulshan Kharbanda ji, sir, please come forward. I would again request Professor Behra and Professor Dharmaraja to please felicitate for his lifetime contribution to the field of education in general and mathematics in particular, with a Samman Pattika, a memento, and a token of hospitality, small token of hospitality from our side. Thank you so much, sir. I would request Professor Behra and Professor Dharmaraja to stay. May I now request Sri Vimlesh Areji, sir, please, presently serving Halwasia Vidya Vihar as its principal, a renowned scholar in Vedic mathematics. He was especially awarded by state government for his formula on short calculations. May I now call upon Sri Kapil Sharma ji, our district mathematics specialist, sir, please. I would request Professor Behra and Professor S. Dharmaraja to please felicitate him with a Samman Pattika, to present him a memento and a small token of hospitality from our side. May I request Professor B.K. Behra to present a small token of hospitality to Professor Dharmaraja. That's a surprise from our side. So please. It's a small surprise from our side, sir. Thank you. Dr. Sachdeva wants to say something again. So please.
मैं माफ़ी चाहता हूँ, मैं एक मिनट के लिए आ रहा हूँ इसमें। मैं अभी सभी के बारे में एक मिनट के लिए बात करना सोचती हूँ। 3-4 दिन पहले मैंने जो है कविता सर से बात की कि सर आप जो है हमारे कॉलेज में आइए और हम सम्मानित करना चाहते हैं। तो सर की एज फर्स्ट ऑफ ऑल हम डिस्कस करना चाहते हैं 70+ की है, मतलब सर रिटायर हो चुके हैं, उसके बावजूद भी मैथ को नहीं छोड़ रहे। मतलब ये उनका कैलिबर कह लीजिए, उनका जज्बा कह लीजिए। फिर मैंने बोला कि सर जो है आप कैसे आएंगे, तो सर बोलते हैं कि मैं ट्रेन से आऊँगा। फिर मैंने कहा कि सर ट्रेन पे जब भी आप आओ ना तो आप बोल देना मैं किसी स्टूडेंट को जो है वहाँ पे ट्रेन पे भेज दूँगा, आप उनके साथ आ जाइएगा। नहीं, मैं पैदल खुद ही आऊँगा। तो इस एज में भी इतना पोलाइटनेस, वो एक मतलब ये कह दीजिए कि शब्द नहीं है उनके कहने के लिए मेरे पास। मैं विमलेश आर्य जी सर के बारे में कहना चाहूँ। विमलेश आर्य जी वैदिक मैथमेटिक्स में ये कह लीजिए भिवानी के जीनियस है, और नंबर ऑफ टाइम्स इनको मैंने कॉलेज के अंदर बच्चों को वर्कशॉप के लिए बुलाया और सर ने आज तक कभी भी मना नहीं किया, इतना टाइट शेड्यूल होने के बावजूद भी। और अभी हमें वैदिक मैथमेटिक्स पे सर ने कुछ मॉडल बनाने के लिए कहा था, डायरेक्टर सर ने, तो मेरे माइंड में आर्य सर आए और मैंने 4 बच्चों को सर के पास भेजा कि आप सर एक आइडिया दे दो वैदिक मैथमेटिक्स पे कैसे मॉडल बनाएं। तो कई तो होते हैं ना कि फॉर्मेलिटी के अंदर 15 मिनट आए, चलो मॉडल दिया, टाइम शेड्यूल टाइट होने की वजह से भेज दिया। सर ने पूरे 2 घंटे प्लस उनको टाइम दिया, उनको समझाया कि आपने मॉडल कैसे बनाना है वैदिक मैथमेटिक्स में। मतलब इस एज में भी आके मैथ को कितना प्यार करते हैं, ये मतलब ये कह लीजिए कि हमारे अंदर वो एनर्जी अभी भी नहीं है, हम उनसे काफ़ी छोटे हैं। आशुतोष सर से मेरी सजस्ट कल या परसों बात हुई है और सर ने 1 मिनट भी मना नहीं किया कि मैं बिजी हूँ, क्योंकि सर गुड़गांव से स्पेशली आए हमारे पास और सर ने कहा ठीक है मैं आ रहा हूँ। मतलब हमारे जितने भी टीचर्स हमने इनको बुलाया है, अपने टाइट शेड्यूल होने के बावजूद भी कॉलेज में आए, इन सब का मैं तहे दिल से धन्यवाद करता हूँ। सर जो है बड़े अभी डीसी से सर की मीटिंग हो रही थी, मुकेश शर्मा सर की, और इनको भी मैंने इनवाइट किया था। तो सर का फ़ोन आया कि मैं बड़ा बिजी हूँ, मैं कहा सर आपको आना है। तो उसकी में मीटिंग छोड़ के सर हमारे पास आए हैं और हमें टाइम दिया है। सर मैं आपका भी अपनी तरफ से बहुत बहुत थैंक यू करता हूँ सर।
Thank you so much, Dr. Sachdeva. There are many events being part of this celebration. Our alumni were also there with us, and 3 of them, Dr. Sandeep Sharma, HOD Engineering and Technology, Andrews Institute of Technology and Management, Gurgaon, Dr. Kavita, HOD Department of Fashion and Design, Government Polytechnic, Chaudhary Balsilal University, Bhiwani, and Mr. Manish Sharma, GBTL, Bhiwani. They were here and judged the event called Open House, the event organized by the students of TIT&S, Bhiwani. May I request our guest of honor, Professor S. Dharmaraj, and our director, Professor B.K. Behra ji, to please present a token of hospitality to Dr. Sandeep Sharma and honor him with a Samman Pattika, sir, please. May I call upon Dr. Kavita, HOD Department of Fashion and Design, CVL Government Polytechnic, Bhiwani. I would request Professor Dharmaraja and Professor B.K. Behra to please present a small token of hospitality and honor her with a Sman Pattika. Dr. Kavita. Dr. Kavita is also an alumnus of this institute. Thank you so much, Professor B.K. Behra. Thank you so much, Professor Dharmaraja. We also had teachers from Rajiv Gandhi Government College, Bhiwani. Unfortunately, I'm not personally familiar with them, but I acknowledge their presence and I thank them for being here as a part of this celebration. Ladies and gentlemen, our next event, that is mathematics quiz, will be held in this central auditorium immediately after the lunch. May I thank you all for being here for this lecture on mathematics. May I request you all to please join us for lunch in the boys' hostel. Please. May I request all the guests, teachers, students and staff to join us for lunch at the boys' hostel.